Google officially announced Wednesday it has achieved quantum supremacy. The tech giant
Vote margins are tightening in favor of Joe Biden after the former vice president narrowly surpassed President Trump in Pennsylvania and Georgia.
It is clear that the Biden-Harris ticket will win the White House.
First theorized the existence of gravitational waves in 1916, upending the world's understanding of physics. And now, after two massive black holes collided nearly 2 billion light years from Earth, astronomers at the LIGO Observatory in Washington state have detected a fourth set of these ripples in the fabric of space-time.
What is gravity? Is it a true scientific construct, or is it simply the product of a scientific cult? What are quantum computers, and what is the statistical improbability of the 2020 elections? Join us as we dive into some very weird science on this episode of The Soul Trap.
Why don't people understand my intelligence?
Well, it's good to have Andrew back with us. We call him our mad scientist. We have covered a lot of material, and some of it has been, quite frankly, just beyond our ability really to even grasp in some ways. But that's what the Bible is. Sometimes we look at the Bible as a devotional book, and it is. We look at the Bible as a doctrinal book, and it is. But don't ever underestimate the scientific and technological aspects of the Bible. I believe the closer we get to the coming of the Lord, we're going to see the technology and science and religion begin to converge more and more in such instances as the singularity, as often quoted by Ray Kurzweil, AI, and now we're talking about quantum physics, biotechnology, nanotechnology. It all seems to be coming to a head. And so it's good to have Andrew with us to be able to talk. A tremendous Christian young man, and one that is well versed in the field of physics and quantum physics. Andrew, it's good to have you with us on the show. The last time we finished talking, we were talking about the black hole. I've watched movies about the black hole. I've read books about the black holes. I don't know if anybody fully, completely knows exactly what they are, but if there's one name associated with the black hole, it is Stephen Hawking. Tell us a little bit about what that is, what the black hole is, what it's theorized, and why is Stephen Hawking so associated with that?
So a black hole, in essence, so when you have a star and it's burning and it starts to die, it starts burning heavier and heavier elements. So what happens is that star is so heavy and so abundant that it starts to collapse in on itself because its matter is so strong. And so what happens, it just keeps crumbling and crumbling and crumbling, and then boom, it creates a black hole. And so it's gravity, and so everything's being sucked into that.
Okay, a hole. Now here's where I want to get to it. A hole in what?
Space. And so we don't actually know what goes on inside a black hole. We have theories, and so one theory is that, matter that gets sucked into it, a star, planet, random particles, light, everything starts getting sucked into it and starts breaking everything down because that's how strong its gravity is. And at the center of that black hole is a singularity of all that matter just coming together and being crushed together. And the theory goes that, maybe that's the beginning of a new universe. Okay. Because that matter is being so crushed that it just explodes. And so that's what a lot of physicists believe. I know, great show, the one that Neil deGrasse Tyson.
Yeah.
If I said his name right, he does that. The Cosmos. He talks about that a lot. And
Carl Sagan used to way back in the day. Yeah.
And so the scientist, Hawking predicted Hawking radiation. And I misquoted, so scientists have found experimental evidence of it, but have not fully proven it. So I misquoted. That was on me. But they, a bunch of scientists and researchers were able to simulate and come up with, possibility of Hawking radiation. Still have been proven fully. And so that's another thing, because we're saying, well, how is that possible? Because forever we have been told that it only sucks things up. And not actually emit things. And so that's another theory that we're having another area that we're having to experiment with, like, what is this Hawking this hypothesized Hawking radiation coming out. And then you have things like white holes, and that is the exact opposite. That thing emits matter, and so if you put a white hole next to a black hole, the black hole will suck in that white hole. And so there's just it's such a vast, the universe is so vast, it's hard for us to even comprehend what goes on out there. In the event horizon, pretty much, if you watch that movie Interstellar, there's that scene in there. That's Hollywood. If we were able to see it, and we've been able to scan through different wavelengths, and that's hypothetically what it could look like. So you have that illusion with light. It kind of goes this way and then it goes up that way. It's because it's being bent by gravity. That's how powerful it is.
Now, one of the things that's fascinating, and I don't want us to digress too much, because I want to come back to the concept of what unifies all these things together. But one of the things that's very interesting is some of the most basic, simple concepts that we maybe in classical physics had assumed or taken by assumption now are being brought into question. One of them is exactly what is space? How do you define space? Is there an ether? And then they say, well, no, there's not. Okay, but what is space? Another one is, how do you define what gravity is? Neil Tyson deGrasse, whatever the guy's name is we were talking about, he was asked, what is gravity? And he said, I don't know. I can tell you what gravity does, but I don't know what it is. And so when you look at these kind of things and you think, man, I mean, at the very base level, once again, I keep coming back to this theme that modern real science is really bumping up against things that, 200 years ago, they were telling us, the Bible's foolish. Now they're going, we don't know what it is. We can tell you what's happening, but we don't know what that is. And so it's very fascinating when you start looking at that. And that's why I've always found the quantum studies, quantum mechanics, very interesting. Now, you mentioned in one of our earlier episodes, one of our earlier shows when we were talking, that there are different fields and branches, and that the Holy Grail is what connects all of it together, what makes all of it work. Explain to us a little bit, I call it the grand theory of everything, the unifying theory of everything. Explain to us what that Holy Grail pursuit is in quantum physics there.
Yeah, so the grand unifying theory is, again, physicists are trying to find ways to connect these forces: the electric weak force, the strong nuclear force, your electromagnetic force, and your gravitational force. Those are the four fundamental forces, and the creme de la creme is fitting it all together into one single equation, expression, and theory. And so there are physicists who dedicate their lives to just that topic alone. So that's pretty much about it. And they call it the theory of everything. They explain it will supposedly explain everything in the universe and how everything functions. And so we touch on gravity.
Is it and I'm sorry to interrupt, is it how it functions, or is it why does it do that? Because we were talking the other night when we were at supper about, you can look at a lot of things, but quantum physics to some degree is almost a philosophy in the sense that it says, why is this doing that? Why is that there in my time-space reality, and yet it's not there? Why is this acting that way? And you've even said, if I remember correctly, that there are certain things that are true within classical physics that when you get to the quantum level, it operates differently, and we don't know why. So is it a why element that people are looking for within that?
I think so. I think they want to figure out the why. They're only solving how. Why is the universe? We're talking deep philosophical questions. That's what physicists, I truly believe, want to know. They want to know why we're here, why this has happened, why the universe created it this way. They want to know why. But they're solving the how. Okay, this is how it did it. And so I think that once they figure out the how, they can start asking the question why, and then they can develop an answer for that.
It's interesting. I'm going to jump in again. It's interesting because I think, now this is from as a preacher, but as both a preacher and a philosopher, I think the approach is, once you know the why, it'll give you more understanding of the how. I know why because of the Bible, and so I think that it allows me to see more of the how. I think it's interesting that they're trying to get at the how, and then they have to scurry around to give an excuse for the why, because the how keeps leading you back to God. You know, in a sense.
Yeah.
Okay, so go back. I keep interrupting. Go back to this idea of unify. What they're looking for is something that plugs everything together and makes it work.
Yeah, that's pretty much it. There's a lot of mathematics behind it. I mean, stuff that is even above me. People who have been doing these differential equations for years, and there's so much research into it. But that's pretty much it. Like, they were able to connect the electric weak force, or the weak nuclear force, and the electromagnetic force, and call it the electroweak force. So they were able to connect that. They found a connection between the two, and so then they're trying to bring in the strong nuclear force, and then they're trying to bring in gravity. So that is so it's a step. So they've proven part of it, but they haven't proven the whole thing.
Okay, you mentioned gravity.
Yeah.
So we know what gravity does. However, that still seems to be a moving target. Even though we know what it does, we're learning, it seems like, from just the journal writings, almost every year we're going, oh, well, it does this more, and we didn't realize that, oh, it doesn't do that. What is the best understanding of what gravity is?
Yeah, so we don't know what it is exactly. So, like I said, classical.
Is it a force?
Yeah, that we treat it as a force. So, the thing about gravity is Newton was the one who discovered gravity, with the apple falling on his head. That's the old wise tale. But he was able to calculate the acceleration due to gravity. So that's what we call little g. That's negative 9.8 meters per second squared.
Okay.
But everybody has gravity. You and I have gravity. The Earth has gravity. And there's, we have a big G constant gravity. But it's varying, okay? So the reason why you and I are stuck on the Earth is because of gravity. But we are feeling gravity from all aspects from the world and from the sun, from the moon. But since we are so close to Earth, the force of gravity only affects someone based upon their mass and distance from set object. So if I was close to the sun, I'm going to feel that gravity and burn up. But since I'm on Earth, I'm affected more upon the Earth's gravity. So we know how it works. And so then Einstein was, his general theory of relativity took into account the behavior of the universe with gravity. And so scientists say, well, think of the universe as a flat sheet. And you throw a basketball on that flat sheet and it's bending.
It bends it down.
That bends it down. That is gravity. That's what they say gravity is.
But the question is, what's the big ball pushing it down in the middle?
What is going on with it? If I threw a wet tennis ball and I threw it in the water flings off, that's because of gravity. And it'll fly up a little bit and then fall back down.
Right.
That's why we have an atmosphere, because the particles are attracted to the Earth. Now some may escape, but not a whole lot. So it stays close to the Earth, and that's why we have the atmosphere. That's why you and I are stuck down here. But I could easily say, oh, it's just a bunch of invisible tiny little hands pulling me down, because we don't know exactly what it is. And the thought experiment behind it is it a push or is it a pull? Because if I'm in an elevator in space, I'm either being pushed from the bottom going up, or I'm being pulled and going up. And so, we don't know. And so physicists are trying to go beyond that reference frame and see what's going on.
Yeah, it's interesting you mentioned, a lot of people don't realize that the early theory, special relativity, not general relativity, but special relativity, was designed, and it was a thought experiment, but it was designed by Einstein to go against something that we talked about earlier, and that was the Michelson-Morley experiment. Because they believed that there was an ether, and one of the things that they believed was that there was an ether that moved. And the theory that they had was that if you were in a boat in the middle of a perfectly still body of water, and you could not see any land, you had no reference point, and the water was you couldn't tell, and you saw another boat out in the distance. and you wanted to know who was moving. Well, am I moving or is the boat moving? What you would do is stick your hand in the water, and if you could feel the wave going across it, you would know I'm moving. So which one of us is moving? In other words, and they were talking about the sun and the earth as a standing position. In other words, their theory was, is it a geocentric earth or a heliocentric model? So that's another thing we'll discuss down the road. So what they believed was that you could stick your hand in the ether, and they felt like that. Well, that really, you can read the writings of Einstein. He did not like that, and he came up with special relativity to say, no, there is no ether. That's when he began dealing with space, with gravity. And as you're talking about gravity, it's a fascinating thing, because it's like, look, we're seeing this stuff operate, but it could just as easily be an invisible hand. We don't actually know what it is that's doing it.
Yeah, and I also think it's some interesting stuff with Einstein. He came up with all these things, and like I said, we haven't proven everything. We've proven parts of it. We proved that time is relative, that it's not constant. So we've proven it, but we recognize it as a full fact and truth. But you have to take a step back and say it's still just a theory.
So as a theory, is it possible, and I'm going to begin to tie this now in hard to the Bible, is it possible that in the future there are things that could still happen that could turn the scientific world on its ear, turn it upside down from the quantum level? Because now they're opening the doors to new gateways, and they're saying we see things happen, but we don't know how to explain that.
Yeah. Quantum mechanics is just, it's such a crazy study. Even Einstein hated quantum mechanics. He hated it.
Really?
He did not like it. Because it wasn't hard evidence. Because at least with relativity and everything, he could show it, and he can show it mathematically, and then we're piecing it all together. We can actually tangibly test it out. But in terms of quantum mechanics, it's such a tiny world down there that we don't really know what's going on, and so we have to use probability calculus. So it could be within this set area. We use statistics. That particle could be in this set area right here. Here's our math to prove it. But we always have a certain level of, what's the word I'm looking for? Uncertainty, the uncertainty principle. There's always going to be a certain level of uncertainty. So then we have to take into statistics as low as possible the uncertainty. We want to keep that as low as possible so we can show that, hey, this is what we have. So it's just such a crazy world, and it's so deep down there. And I do think that, when the end times get here, however the Antichrist comes on board, he's going to have a vast understanding of quantum physics and physics in general, because he is full of parlor tricks, and so he's going to have to be able to mimic what God can do to deceive people. And so you have to have a vast understanding of physics and mathematics and biology, chemistry. You have to understand how everything works to pull off a counterfeit of
Very
everything.
interesting.
Yeah.
All right, so we're going to take a turn to the left here. Let's talk about something that you probably are not, as listeners, necessarily going to put 2 and 8 together rather than 2 and 2. Let's talk about election results, quantum physics, and computers.
Yeah.
The other night, Andrew and I were sitting around the fire, and we began to talk about the election results and how things happen. We began to talk about Chinese computers. I had no idea about the connection between quantum physics, or the quantum element, and the new cutting edge technology of quantum computers. Tell us a little bit about how close we are to Skynet and computers running the world and the Matrix.
So I personally don't think that we can create an artificial intelligence. God is a personage. That's being very honest. God is a personage, and who we are is because of him. He designed us that way. He's like an architect. But we don't even understand everything about ourselves unless we go to the Bible. So I don't think we can create a artificial intelligence. So with quantum computers, that's really interesting. Quantum computers, I don't know too much about it, but I do know that governments worldwide are funding it. It's just like the nuclear arms race.
Okay, so this is like the nuclear arms race. This is more important than anything else to them. They want this.
They want quantum computers because quantum computers would be able to, they run so fast, faster than supercomputers, I might add. And they would be able to break code and encryptions, and whoever has a quantum computer, whatever nation has that quantum computer, would be able to hack into their systems, take their nuclear codes, find out all the information they want. That's how powerful these things are. They can think, and so a regular computer works on binary, 0, 1, 1, 0. Well, a quantum computer works similarly. It runs on 0, 1 like that, but it measures it in amplitudes. So it doesn't care about -1. Okay, I usually think of, you don't have a negative 30% chance of rain. You have either 0 or 30. So what these quantum computers do, and they have qubits, quantum bits, and they measure the amplitude, and so this gets into quantum entanglement. That's when you can either have a 0 or a 1 or both at the same time. That's your quantum entanglement.
Okay.
And so these computers are shifting through that, and so for example, I know I talked about this last night. A computer to code in a molecule for a coffee bean would take a computer years and years to do.
To code in the DNA molecule. Okay.
Yeah, and so supercomputers, we just don't have that capability, the even the storage capacity to do that. But a quantum computer would be able to do that. It would be able to decode things. It'd be able to think very fast. I don't think it'll have a personality or anything, but it would be able to think super quick, and you can plug in.
You don't think it's going to have a personality? That's your hope. Okay, so to get a gist, so that you can kind of get an idea, you tell me if you tell me what you think if I'm off. So you've got a regular computer. It's going to take 10 years to do something. I'm trying to give you an example of what we're talking about. Regular computer will take 10 years. Supercomputer would take a year. A quantum computer,
matter of seconds. Yeah. Because
even nanoseconds.
Yeah. These things, like Google claimed they had quantum supremacy, and IBM called them out and said, no, that's not true. These things just are so, the way, because we're talking about at the quantum state. We're not talking about numbers in like 0, 1. We're not even talking about electrical, because it's running electrically. This thing is running quantumly. This thing is running on the particles, and the particles are shifting through the qubits and everything. It's crazy stuff. This is stuff that's even going above my head. These engineers are very brilliant people in terms of these qubits, and the Chinese have actually, they're claiming quantum supremacy. So the engineering aspect is what's so difficult about quantum computers, because you have to keep the computer super cold. Like we're using liquid helium. We're keeping it as cold as possible. And
they have to use liquid helium to cool the computer because it's operating at such a fast level.
You have to preserve everything. You can't expose it to the environment around, or it'll destroy the computer. But the Chinese are saying, I think my professor told me about it, that the Chinese were able to use light. I haven't been able to do a whole lot of research about it, but that's what the Chinese are claiming. Some crazy stuff was going on.
Okay, so the Chinese are claiming that they have dominion when it comes to quantum computers. No pun intended.
And when we mean quantum supremacy, so no actual quantum computer has been created yet. What we mean is quantum supremacy means we have something very close to it. We're gaining that supremacy. We're ahead of you. That's what they're claiming. And so they have prototypes. I think Google, some company has claimed that they I want to say it was Google, claimed that they have some quantum supremacy. And I've seen, prototypes of, 64 qubits, something around that. I'm getting a ballpark. Because quantum computers is not my real area of expertise, but that's pretty much what a quantum computer does. And so now, so in order to go back, kind of piggyback on for the funny stuff, when I was watching the election thing in Pennsylvania, I was watching that with Rudy Giuliani giving a testimony. The statistics don't add up. it's some crazy stuff was going
Yeah,
on.
yeah.
So, you know, numbers don't lie when you're using stats. You can't fib in statistics. It's a very hard science.
Yeah.
And you're giving, you know, the possibility, the probability, what is happening, what's the likeliness of this happening. And so, you know, Trump's ahead by X amount of votes, then all of a sudden Biden gets all these votes, not just to match him up, but to get ahead of him. But then only a handful of those votes go to Trump. And so you have these weird statistical spikes that aren't adding up. And so that raises a lot of questions, like, where did you get these votes? Because you know, the mail-in votes are coming in. The people already have them. They've already started doing that. It's closed. What's going on? And so this had to have been, you know, the election had, you know, I truly, honestly believe there was some form of fraud.
Oh yeah.
And so I truly believe that there was, you know, this has been planned for years.
Yeah.
And so I know I told you, I think when President Trump won Florida, when he won Florida, that's when I think the Democrats or whoever, some power, realized he was going to win. Because no president has won the presidency without Florida ever before, until now. Then all of a sudden you have Georgia, you have Pennsylvania, Michigan, Wisconsin, and Arizona. You have these 5 states all of a sudden turn blue. And I was up until about 4 or 5 o'clock in the morning watching the results.
Yeah.
And they weren't calling it. Trump was ahead in some states, hundreds of thousands of votes.
Yes.
And you're like, what is going on? Why aren't they calling it? And then Joe Biden comes out and he's like, we knew this was going to happen. We knew that with the mail-in votes, this was going to happen. And you watch One American News, you're seeing people pull out boxes of mail-in votes and just start scanning it multiple times. So you have to ask yourself, how well planned was this? Because this didn't happen because a bunch of poll workers were getting angry and Trump was winning. This had to have been planned. They had to have had a backup plan for everything. Because I truly think they chose Biden. The Democrats chose Biden because that he would possibly get moderates and independents over to their side, but he couldn't do it. And then they chose Kamala Harris, and Kamala Harris was not winning the primaries. She was doing horribly.
Yeah.
But then they choose her to be the vice president. And so, and you're watching Biden and you're thinking, what is going on with this guy? He doesn't sound coherent.
What he's got some quantum entanglement in his mind.
True international average of pressure.
Going on there. So something's messing up. His circuitry's off. And so you're like, what's going on? And so I think that there was a big conspiracy going on because the math does not add up. And as a mathematician, you're looking at the numbers going, that doesn't make sense. I'm not a poli-sci student. I took my basic courses. So all the constitutionality stuff, that goes over my head. So, I don't know it. But as a math person, I'm thinking, that doesn't make sense. How in the world are there more votes than voters? How in the world was Biden able to beat Trump overnight? And people went to bed. I stayed up watching it.
I know.
I stayed up watching it. And they should have called the election by 10 o'clock my time, because that's how far ahead he was. All the states were turning red. I mean, all these states, other than your usual blue states, were turning solid red. And so, like I said, these statisticians are saying, look, there was a spike.
What an interesting thing in history. It may very well have been the first coup d'etat, an insurrection. Not by revolutionaries carrying guns, but by mathematicians punching computer keys. Well, there you have it, ladies and gentlemen, the Mad Scientist. We've talked about everything from politics to physics. We hope you've enjoyed having Andrew with us, a tremendous young man of God. Pray for him. We've enjoyed and learned a lot with him. We hope you've enjoyed these shows, and as we like to say around here, we hope that this episode finds you on that
good and narrow way.
Amen. God be with you. See you soon.
It's science.
Science! Science!
It's science.